So we've got the Pythagorean theorem, which allows us to take two sides of a right triangle and get the third. Now we're going to extend this into angles a little bit, and eventually we'll get into trigonometry and do a lot more. But for today, this lesson, we're going to look at 45, 45, 90 right triangles. So one angle's 45, another's 45 and 90, and 30, 60, 90. So 30 here, 60, and this is 90. So let's look at 45, 45, 90 first. Because these two angles are the same, it's isosceles, so these two sides are the same. So what we can do is start with our Pythagorean theorem. A squared plus b squared is equal to c squared. But because the legs are the same length, we have a squared plus a squared is c squared. Simplifying a little bit, take a square root of both sides. Separate these, and we get rad 2 times a is equal to c. And therefore, c is either a rad 2 or rad 2a. You could do it either way. Okay, so c is equal to rad 2a. So whatever this side is rad 2 times that amount. Or to go from 90 to 45, you have to divide by rad 2. To go from rad 2a to a, divide by rad 2. Now let's take a look at 30, 60, 90. For 30, 60, 90, start with an equilateral triangle. So we'll say every side is 2a. So this is 2a, this is 2a. Here we have a and a, it's 2a. You drop an altitude down the middle. And now we'll just take a look at this triangle over here. So this is 2a. This is now only a because it's cut this third side in half, this bottom side. So that's a. Now we're trying to find out what this height is, the last side of the triangle on the right side. So now really we're only focusing on this triangle here. And again, we'll use the Pythagorean theorem. So we're going to have a squared plus b squared is c squared. But now our hypotenuse is 2a. So simplifying, a squared plus b squared is this now becomes 4a squared. Subtract the a squareds, take a square root of both sides. Separate those. And so therefore that third side, the side opposite the 60-degree angle, is either rad 3a or a rad 3. Okay? So in a 45, 45, 90, the two shorter sides a and a, longer side rad 2a, 30, 60, 90. The side when I say the 30 side, I mean the side opposite the 30 is a. The side opposite the 60 is rad 3a. The side opposite the 90 is 2a. So the a sides, or the 30 side is a, 60 sides rad 3a, 90 sides 2a. This is putting all that information in ratio form. So 30, 60, 90, 1 rad 3, 2. 45, 45, 90, 1, 1 rad 2. So in a triangle, to go from the 30 to the 90 side, going from 1 to 2, you have to double. So here to here, multiply by 2. If you're going the other direction, you'd have to divide by 2. 30 to 60, multiply by rad 3. Rad 3 back to 1, that is 60 back to 30. You divide by rad 3. Going between rad 3 and 2 is a little problematic, so going between the 60 and the 90, it's easier just to go to the 30 than the 60 along the way. Now for 45, 45, 90. Going from either one of the 45 sides to the 90, 1 to rad 2, you multiply by rad 2. If you're going from 90 back to either one of the 45s, you divide by rad 2. So one more time, looking at this in terms of triangles, we see that right here. So 45, 45, 90. These are both 45, so x, x, x rad 2. 30, 60, 90, so x, x rad 3, 2x. So now some practice. Do several problems. All right. Number 1. This is a 30, 60, 90 triangle. You have the side opposite the 30. To go from 30 to the 60, you multiply by radical 3. 1 times rad 3 is rad 3. To go from the 30 side to the 90, you multiply by 2. 1 times 2 is 2. Over here, now we have the side opposite the 90. Don't go from 90 to 60, go from 90 to 30, it's easier. So to go from the 90 side to the 30 side, that was going from 2 to 1, so you're dividing by 2. So this is 4.5. To go from the 30 side to the 60 side, that's 1 to radical 3, 4.5 radical 3. Again, another 30, 60, 90. This time we have the side opposite the 60. Okay, so quick look back at this. 30, 60, 90. To go from the 60 side to the 30 side, you would have to divide by rad 3 because you're going from rad 3 to 1. So 60 side to 30 side, divide by radical 3, so it's 25 over rad 3. Multiply top and bottom by rad 3, you get 25 radical 3 over 3. To go from the 30 side to the 90 side, that's multiplying by 2, and 2 times 25 rad 3 over 3 is 50 radical 3 over 3. Now, because these are the same length, this is a 45, 45, 90 right triangle. And so the short side to the long side in 45, 45, 90, you multiply by rad 2. So whatever this is, multiply it by radical 2. Okay, so this is 8 rad 2, since we multiplied by rad 2 to get to here. Now moving over to this problem, because these are both y, we know it's a 45, 45, 90 right triangle, again. But now we've got the long side. To go from the 90 side to the 45 side, we have to divide by radical 2. So multiply top and bottom by rad 2 to rationalize the denominator. Rad 2 times rad 2 is, of course, 2. So this becomes 14 radical 2 for both of these. They're both the same. And then over here, if we take a square and we cut it in half, then we got a 45, 45, 90 right triangle. So 6 is the long side, s is the short side, so we do 6 divided by radical 2, rad 2 over rad 2, which is 6 rad 2 over 2. So each s is equal to 3 radical 2. Okay, a couple word problems. Length of a diagonal of a square 30 centimeters on a side. So here's the square, 30, 30. Make a diagonal. This is a 45, 45, 90 right triangle because these are the same length, so these angles are the same. And so to go from the short side to the long side, we multiply by a radical 2 and a 45, 45, 90. Here we've got a 30, 60, 90. Short leg is 6. Find the length of the other two sides. So this is 30, which implies this one must be 60, and the short side's 6. Oh, excuse me. This would be 6, since the short side is opposite the 30. So this would be 60 degrees, not really to scale. So to go from the short side to the long side, multiply by 2. To go from the short side to the side opposite the 60, the middle side, multiply by radical 3. Okay, one more problem on here. I can cut this down here, and so now if this is 2 rad 3, I know this length is 2 rad 3. That's opposite the 60, which means that to go from the 60 to the 30, there's 30, that's a right angle, we would have to divide by rad 3. So 2 rad 3 over rad 3, this becomes a 2. To go from the side opposite the 30 to the side opposite the 90, you multiply by 2. 2 times 2 is 4, so A is 4. Now, if this whole thing here is 5, and this one little piece is 2, that means B must be equal to 3. And finally, one more larger connected problem. This is a 45, 45, 90 connected to 30, 60, 90, 45, 45, 90, 30, 60, 90, 30, 60, 90, 45, 45, 90. So, starting at the 45, 45, 90, this is 2, so this is 2. That's going to make this 2 radical 2 because you multiply by rad 2. That's opposite the 90. To go from 90 to 30, divide by 2. To go from 30 to 60, multiply by radical 3. Rad 3 times rad 3, 2. Sorry, rad 3 times rad 2 is rad 6. That means this is also rad 6 because now this is a 45, 45, 90. To go from 45 side to the 90 side, multiply by rad 2, so you get rad 12, which is equal to 2 radical 3, because this is a rad 4 times rad 3, so that's 2 rad 3. That's the 90 side. The 30 side's down here, divide by 2, so this becomes rad 3. To go from the 30 side to the 60 side, multiply by rad 3. Rad 3 times 3 is 3. These are symmetric, so this is going to be 3. This will be 2 rad 3. Finally, a 45, 45, 90, so this is 3. And then going from the 45 side to the 90 side, you multiply by radical 2, 3 rad 2.